Close your eyes and imagine the final sunset. Not the sunset of a day or the end of a year, but the final sunset of our universe. We live in a brief, shimmering moment of cosmic history, a fleeting era of light and heat that we call home. Around us, hundreds of billions of galaxies dance in the dark, each holding hundreds of billions of stars. It feels eternal. It feels like it has always been this way, and always will be. But reality is far more fragile, deep within the fabric of space and time. A silent clock is ticking. It is a law of nature that cannot be broken, a slow descent into a state of total disorder. We call it entropy. It is the ultimate architect of our destiny. From the moment the Big Bang ignited the first spark of existence, the universe began its long, inevitable journey toward the cold. So today, we are voyagers on a journey through time, not across centuries or millennia, but across trillions and quadrillions of years. We are going to witness the death of the very last star. We are going to watch as black holes, the kings of the dark, slowly evaporate into nothingness. Welcome to the end of everything. This is the story of the heat death. To understand the end, we must look at where we are now. Astronomers call our current time the Stelliferous Era, the Age of Stars. It is a golden age where gravity pulls vast clouds of gas and dust together to ignite fusion. It is a time of brilliance, of warmth, and of life. But the fuel is not infinite. Every star you see in the night sky is a candle burning down. Some burn fast and bright, dying in violent, beautiful explosions. Others, like the small red dwarfs, burn slowly, sipping their fuel for trillions of years. But eventually, even the most patient fires must go out. On and by one, the lights of the cosmos will begin to blink out. Imagine a galaxy, once a swirling disk of silver and gold, slowly turning gray. The great nebulas, the nurseries where stars are born, will run out of gas. No new stars will take the place of the old. The universe will become a graveyard of white dwarfs, neutron stars, and black holes. This is the beginning of the end, a slow fade into a twilight that will last longer than we can possibly imagine. By the year 100 trillion, the era of the stars comes to a silent, shivering close. The very last red dwarf, a star that has clung to life for longer than 1,000 generations of our own sun, finally exhausts its fuel. It does not go out with a bang. There is no grand explosion, no final display of cosmic fireworks. It simply fades, a dim ember cooling in an attic that has grown infinitely large. With its passing, the lights of the universe are extinguished forever. We now enter the degenerate era. The cosmos is no longer a place of fire and light, but a graveyard of giants. The remnants of stars, white dwarfs, neutron stars, and the cold, dark husks known as black dwarfs, drift through a void that is expanding faster than the speed of light. These black dwarfs are theoretical objects, stars that have cooled so much they no longer emit heat or radiance. They are the frozen ghosts of a vibrant past, silent monuments to a history that no one is left to remember. In this era, time begins to stretch in ways the human mind cannot fathom. The intervals between cosmic events are no longer measured in millions of years, but in numbers followed by dozens of zeros. The universe is becoming incredibly lonely. Because of the constant expansion of space, every dead star and every cold planet is pushed so far apart that they will never see another object again. Each one becomes a solitary prisoner in its own observable universe. But even the solid matter of these dead stars may not be permanent. Many scientists believe that protons, the very building blocks of atoms, are not eternal over vast, inconceivable spans of time. Matter itself may begin to dissolve. If protons decay, the solid remains of our universe will slowly evaporate into thin mists of radiation. The rocks, the dead planets, and the cold hearts of stars will simply vanish into the vacuum. What remains are the true kings of the darkness, black holes. In a universe where matter has dissolved and stars have faded, black holes become the only structures of any significance. They grow to monstrous sizes, swallowing the stray particles of a dead cosmos. They are the ultimate scavengers. For a period of time so long it defies any name, the universe will belong to them. But even these titans, the most powerful objects in existence, are not immune to the laws of entropy. A silent, invisible process is already at work, a slow leak discovered by Stephen Hawking. Even as they rule the darkness, the black holes are slowly, atom by atom, bleeding away. The scale of time we are now discussing is beyond human language. To describe the lifespan of a black hole, we must use numbers like 10 to the power of 100, a number so large that if you wrote a zero on every single atom in the observable universe, you would still run out of atoms before you finished writing the number. Yet, as the eons pass, even these giants succumb to the invisible leak of Hawking radiation. Slowly, they lose mass. As they get smaller, they burn hotter. In their final moments, after living for trillions upon trillions of years, the last black holes will end their lives in a sudden, brilliant flash of light. A tiny spark in an infinite desert of darkness. And then there is nothing. The universe has reached its final state. This is the heat death. It is a misleading name, for it is the coldest the universe will ever be. It refers to the death of heat itself. Every corner of space is now at the exact same temperature. There is no more energy to be transferred. There are no more gradients, no more flow. In physics, work requires a difference in temperature. Without that difference, nothing can ever happen again. No star will ever ignite. No heart will ever beat. No thought will ever be formed. Even time itself becomes meaningless. If an eternity passes and nothing changes, does time truly exist? The universe becomes a thin, endless soup of stray photons and electrons, drifting aimlessly through a void that is trillions of light years across. Every particle is so far from another that they will never meet. They are travelers in a sea of nothingness that has no shore. The story of our universe is a story of a single long exhale. We find ourselves living in the very first milliseconds of that breath. We live in the era of light, a brief and beautiful moment where the laws of physics allowed for the complexity of stars, the birth of planets, and the miracle of consciousness. We are the universe's way of looking back at itself and marveling at its own brief radiance. As we look up at the night sky today, we should not see the darkness as a threat, but as a frame that makes the light of our stars, our world, and our lives more precious. For we are the witnesses of the golden age. We are the ones who got to see the lights before the long, eternal silence. The universe began in a flash of heat and light. It ends in a whisper of cold and dark, and in between, for a fleeting moment, there was us.